morning, students. In the previous lecture we have seen the completing square method for solving quadratic equation. Okay, we will do one more question of this method, that is 8x square plus bx plus c is equal to 0. Okay, so I am solving it by using completing the square method. For that, I need to divide this complete equation by a in order to make the coefficient of x square as 1. I need to divide this complete equation by a. So I am dividing 1 by a. What I will get is a by a x square plus b by a x plus c by a is equal to 0. Okay, now a gets cancelled. Moving forward to second step. The second step is we shift the constant term to the right part. Okay, so this is our constant term c by a. We will shift it towards the right. What I will get is x square plus b by a x is equal to minus of c by a. Okay, now the next step, what we take is the half of coefficient of x. Okay, half of coefficient of x will become b by 2a, and we add its square to both sides. So x square plus b by a x, and half of coefficient of x is b by 2a, and we add its square to both sides. Okay. Now see what happens. This a square plus b square plus 2ab becomes a plus b whole square, and here we have minus of c by a plus b square upon 4a square. Okay. Now more. When we remove square from this side, we put square root to this side. Okay, so see, LCM of a and 4a square will be 4a square. What we now get is x plus b by 2a is equal to, LCM is 4a square. Now see, here we have a, so we need to multiply 4a, so we get minus of 4ac plus b square. Now one thing I forgot, whenever we put root, we get both positive and negative. So we have both plus and minus. Now see, 4a square is a complete square and its square root is 1 by 2a, and we have under root b square minus 4ac. See, we need value of x, So this b by 2a will shift to that side and it becomes negative. So minus b by 2a plus minus under root b square minus 4ac by 2a. This implies the value of x will be minus b plus minus under root b square minus 4ac upon 2a. Dear students, this is the formula for solving the quadratic equation minus b plus minus under root b square minus 4ac by 2a. Remember one thing, this formula was given by Sridhar Acharya of Ujjain. Yes, this formula was discovered by Sridhar Acharya of Ujjain. Now this b square minus 4ac, b square minus 4ac is known as discriminant and is denoted by capital D. So in short, we can also write formula as x equal to minus b plus minus under root d upon 2a. Now see, here there are plus sign and minus sign and the values of x are known as the roots of equation. I repeat, the values of x are known as roots of equation. Now, these roots are generally alpha and beta. Most likely in alpha we take positive sign and in case of beta we take negative sign. Okay, so this is the study about roots of equation and how we get the formula for solving the quadratic equation. Now we will study the characteristics of roots of equation. Okay, so we have seen b is equal to b square minus 4ac. Now we will study about nature of roots. Okay. Based on the nature of this d, we can predict the nature of roots. See how? There are three cases. The first case, if d is greater than 0, d means discriminant. Discriminant is greater than 0. Greater than 0 means positive. Okay, b square minus 4ac is positive. Then what we say, that the roots are real and different. Okay, if the value of d is greater than 0, then the roots are real and different. Now comes to case second. What does case second say? If d is equal to 0, d is equal to 0, then it means that it is neither positive nor negative. In such a case, the roots are real as well as same. In this case, the roots are real and same. And the last one, if b is less than 0. Less than 0, that means the value of discriminant is negative. In such a case, we say that the roots are imaginary or imaginary, or we can say non-real. Okay. So there are three cases in order to identify the nature of roots. The first one is if b is positive, that means the value of discriminant, that is b square minus 4ac, is greater than 0. We say that the roots are real and different. Second one, if b is equal to 0, we say that the roots are real as well as they are same. And the third one, if b is less than 0, we say that the roots are imaginary. Now, let us see the example of all these three cases. Okay, so suppose I have x square minus 5x plus 6. Now I am comparing it with ax square plus bx plus c. What I get, a is equal to the coefficient of x square is 1, coefficient of x is minus of 5, and coefficient of the constant term is 6. So I need to find b. B is equal to b square minus 4ac. So solving it further, what is b is minus of 5, a is 1 and c is 6. So what I get here is 25 minus 24, which is equal to 1. 1 is greater than 0. So in this case, d is greater than 0. So I can say that the roots of these equation will be real and different. This is example of the first case. Now consider one more example. Suppose I have x square plus 4x plus 4. Now I have explained you here that how we get ABC. So I have A as 1, B as 4 and C is also 4. Now I need to find D, which is b square minus 4ac. See what I get, 4 square minus 4 into 1 into 4, which is 16 minus 16 is equal to 0. So the value of d is here 0. So which is second case here. So I can write that the roots of this equation are real as well as equal. Okay, now as we have seen the second case, similarly I can see the third case. Suppose I have equation as x square plus 4x plus 5. Now what we have, a here is 1, b is 4 and c is 5, and the formula for d is b square minus 4ac. Just Write down the values. B is 4. So 4 square minus 4. A is 1 and C is 5. What I get is 16 minus 20, which is minus 4. See, negative, that means D is less than 0. So in this case, in such a equation, I can say that the roots are non-real. Okay, so this is the way to identify the nature of roots. Once again, I repeat, if the value of D is positive, the roots are real at different. If value of D is 0, the roots are real as well as same. And if the value of D is negative, that is less than 0, we say that the roots are non-real. Okay. Okay. So in the examples we have seen that the roots, when the roots are real and different, when they are same, and when they will be imaginary. So demonstrating the same example, now what we are doing, we are solving the quadratic equation using the formula method. Okay, so what was first example was x square plus 5x plus 6. Okay, now see, comparing with ax square plus bx plus c equal to 0. Okay, now the coefficient of x square here is 1. What I get, the value of a is 1, that of b is 5 and c is 6. Okay, so what we are doing, we are solving this quadratic equation using formula method. So what was the formula? Formula was x is equal to minus b plus minus under root d upon 2a. Now I need to find the value of this d. So d was b square minus 4ac. Okay, b is, see, b, the value of b is 5. So 5 square minus a is 1 and c is 6. So I get 25 minus 24, which is equal to 1. And we have seen the same example there, that d is greater than 1. So from here we can find that the roots of this equation will be real and different. So let us find the roots now. What my x will be? Minus of b. The value of b is 5. So minus of 5 plus minus under root d. I have got the value of d. d is 1 upon 2a. The value of a is 1. So minus 5 plus minus root 1 is 1 by 2. Now see, we will get two different values. One value we will get when we take the positive sign. This positive negative, so I am taking the positive sign. What will be x is minus 5 plus 1 by 2, which is equal to minus 4 by 2. So the one value of x will be minus 2. Similarly, when I take negative sign, what I will get? X equal to minus 5 minus 1 by 2, which is equal to minus 6 by 2, which which is equal to minus of 3. So I have got the two values of x. X is equal to minus 2 or x is equal to minus of 3. Okay, I hope you understood. Very simple. Just find out A, B, C and put down in the formula and we can get the values of x. Okay, so what was our second question? It was x square plus 4x plus 4. Okay, see demonstration. Minus 2 minus 3 are basically alpha and beta. See, these are the roots. Okay, they are real. Yes, they are real. And are they same? No. So when d is greater than 0, the roots will be real and different. Now see this case. Okay. For solving, I need to compare it with ax square plus bx plus c equal to 0. What I get is a equal to 1, b is equal to 4 and c is also equal to 4. Now, what is the formula? Formula is minus b plus minus under root d upon 2a. Okay, just find d. D is b square minus 4ac. The value of b is 4, a is 1 and c is 4. Just put down the values. Okay, what I get? 16 minus 16 is equal to 0. So the value of b is 0. Definitely in this equation the roots will be same. Now let's see. X equal to minus b. The value of b is 4. So minus 4 plus minus under root 0 upon 2a. So 2 into 1. The root of 0 is 0. Now you take positive what will be x is minus 4 by 2 which is equal to minus of 2, and when I take negative it will be also same because minus 4 minus 0 is also minus 4. So see, the roots are same when the value of discriminant is 0. Okay. Now just see one more case. Was x square plus 4x plus 5 is equal to 0. Now see, comparing with ax square plus bx plus c equal to 0, what I will get is a equal to 1, b is equal to 4 and c is equal to 5. Okay, now what is x is minus b plus minus under root d by 2a. This is the formula, and d is b square minus 4ac. Just check it out. B is 4, A is 1 and C is 5. So what I will get is 16 minus 20 is minus of 4. Now just put down the value. Minus b plus minus under root minus 4 by 2 into 1. Now see, the negative inside square root is non-real. So we can directly write here, after just seeing the value, whenever d comes negative, you can directly write it that the solution, or instead of solution you can write that the roots of given equation are non-real. Okay, and since the roots are non-real, we cannot solve it further.